Welcome, detectives. My name is Jason Richards, Microsoft Technical Trainer and Data Detective. Fabric notebooks are interactive documents that allow you to write and execute code, add comments, and visualize data. They're powerful tools for data analysis and experimentation, as well as automation and orchestration. Together, we'll investigate how to use Fabric notebooks to connect to external data sources, ingest and transform data in a lakehouse, write data in different formats, and optimize performance and scalability. We'll also consider how different users and roles can benefit from Fabric notebooks and how to transform data for different purposes. Grab your magnifying glasses, not with that big ol' eye, but with yours, and let's solve the case of notorious notebooks. Fabric notebooks are documents that combine code, markdown, and output in a web-based interface. You can use Fabric notebooks to write and run code in various languages like PySpark, Scala, R, and Spark SQL. You can also add markdown cells to provide comments, explanations, or instructions. The output cells show the results of your code execution, such as tables, charts, or graphs, and errors if you screw up. You can run or freeze individual or multiple cells depending on your needs. Fabric notebooks are great for exploring data, testing hypotheses, prototyping solutions, and automating workflows. One of the main use cases for Fabric notebooks is to ingest and transform data from various sources and load them into a lakehouse. A lakehouse is a hybrid data platform that combines the best features of a data lake and a data warehouse. It allows you to store and process structured, semi-structured, and unstructured data in a scalable and performant way. Fabric notebooks provide a comprehensive, automated solution for data ingestion and transformation, as opposed to manual uploads or data flows, which have some limitations. Fabric notebooks also leverage the Spark engine, which enables a distributed and parallel processing of large data sets. In other words, if you like control, flexibility, and performance when performing ETL operations, and are familiar with one of the programming languages mentioned, then notebooks may be your most important tool in your detective kit. So how do we get started working with notebooks? Glad you asked. Fabric notebooks can connect to and ingest data from a variety of external sources like Azure Blob Storage, Azure SQL Database, Synapse Analytics, and others. You can use Fabric shortcuts to easily access some of these sources, or you can programmatically connect to them using code. For example, to connect to Azure Blob Storage, you can use Shared Access Signatures, or SAS tokens, and construct a path for the connection. To connect to Azure SQL Database, you can use a service principal, which in essence is like your detective badge. It's an identity with permissions attached to it. Then you can build a Java database connection, or JDBC URL, which is a generic Java database connector. You can also use different authentication types depending on the source and security requirements. Once you connect to a source, you can read the data into a Spark data frame and manipulate it as you need. Great, flexibility in connecting to different data sources. Now that we have our data, what can we do with it? Another mystery, detectives. Lakehouses support structured, semi-structured, and unstructured files. Load as Parquet file or Delta tables to take advantage of the Spark engine. OneLake supports a wide variety of file formats, including many formats that are commonly used in Spark code, like delimited text, JSON, not this one, Parquet, Avro, ORC, and others. In most cases, Parquet is the preferred format because of its optimized columnar storage structure and efficient compression capabilities. Parquet is also the base format on which Delta tables in a lakehouse are based. To write data to a lakehouse, you can use the write method and specify the format, mode, and path or table name. For example, to write a data frame to a Parquet file, you can use the write.parquet method shown here and provide the output path. Delta tables are one of the key features of Fabric lakehouses. You can easily ingest and load your external data into Delta table via notebooks. Delta tables are covered in more depth in another case, so use your investigating skills to track it down. For enterprise-level data scenarios, write optimization is key. Consider these optimization functions for even more performant data ingestion when writing data to Parquet and Delta-type files. V-order enables faster and more efficient reads by various compute engines such as Power BI, SQL, and Spark. V-order applies special sorting, distribution, encoding, and compression on Parquet files at write time. The optimize write improves the performance and reliability by reducing the number of files written and increasing their size. It's useful for scenarios where Delta tables have suboptimal or non-standard file sizes, or where extra write latency is tolerable. Before you move to the next steps of your data analysis and modeling, you should consider who will be using the data and how they'll be using it differently. Different users and roles may have different preferences and requirements for data ingestion and transformation. For example, data scientists may want to access the raw ingested data and explore wide tables with minimal changes. They can use Fabric's Data Wrangler to interactively explore data and generate transformation code for their specific needs. On the other hand, data analysts may need more transformation and modeling before they can use the data in Power BI. They may prefer more narrow tables with more changes and aggregations. While Power BI can also transform data, starting with well-prepared data allows analysts to develop reports and insights more efficiently. Once again, the trusty DetectoLab 5000 is prepped and ready to apply the knowledge we learned to practice. Ready to wrap up this case? The game is afoot.
Welcome back to our environment, and we're going to talk about notebooks. So we've talked about Spark, we talked about Delta tables, but we haven't really gone over the notebook experience. And I got to say that, the Jupyter Notebook type interactive development environment, or IDE, is really one of my more favorite ones, even a little bit better than the Databricks, although it does have its benefits in there. But just to make a point, or just to call it out, is that in order to load notebooks into this environment, it's got to be in an IPYMB format. So IPYMB file extension is what the file kind of looks like. It doesn't really list it as IPYMB here, but you'll know it's a notebook and it has to be an IPYMB file in order for it to do that. I might be able to, if I went into, let's see, I don't think this gets saved in the actual Lakehouse. It just gets saved in the workspace items. So yeah, I don't see it in here, but I do have them in here. So IPYMB, so you can see that I have an IPYMB file extension. As long as it has that in there, you'll be able to load these file into a notebook. If not, then you can always go into convert. There's a lot of different programs and coding that you can utilize to convert files from one format to another one and be able to load it. Just know that it might change the way that it looks when you bring it in. It always seems to do that. So, besides the point, we're here to talk about notebooks, right? So there's a couple ways, or few ways, that we can load notebooks in. We can go directly into the experience, so the data engineering experience, and import notebooks or open notebooks, find our notebooks that way. There's also data science, also utilizes notebook experiences. We can do it there. We can also do it directly from our workspace. So I can open up a notebook or create a new notebook and associate it with that. And if I'm in my Lakehouse item, so if I'm in my Lakehouse itself in the Explorer part, I can open up a notebook. And what this will do is this will actually attach the Lakehouse as a resource or as part of the Explorer. So when it's going to look up files and you're naming file paths in the notebook, it'll know that that's where I'm trying to pull the files out of. But just to show what that means without that, we'll go into this and we'll just open up this notebook, which has been already saved in here. So when I see the Explorer, see there's these resources. So I have built-in resources, which I don't have any yet. and I have lake houses, which I do. So what I want to do is I want to add this lake house data source in here. I have that. I'm going to add it in here because I'm going to be working with this. So what I'm doing here is I'm attaching this to it so that it knows now that I have one item added. So if I'm referencing file paths in here, then it knows where to grab it. Or if I'm referencing tables, it should be able to grab that from the Explorer, right? Because I have those fact sale, dimension date, and dimension city here in my tables. Boom, I know that this is happening. So the first thing I need to do is make sure that I'm associating this with the file paths that are being identified in here with the resource that I have connected. All right, notebook experience itself. Notebooks in and of themselves if we went through the ribbon, we might as well just go through that. I can save, I can download, I can change settings, I can run all the cells, or I can run cells above or below. When the session starts, and usually when you execute the first cell is when it attaches to a session. So it's attaching to a Spark session, a Livy session, or managed by Livy or Livy or whatever you want to say in that. And then that's what we execute off of. So there's a certain core capacity that is reserved for your session. So if somebody else wants to run in that session, they may go over core requirements or something like that. So always make sure that when you're done. Now these will automatically stop after there's a timeout that usually occurs with these, where it'll stop the session. Anything held in memory at that point will disappear. So keep that in mind. But when you stop the session, then you're freeing up those compute options for somebody else to run it, or for another process to run it. But those are things like high concurrency and vertically scaling or horizontally scaling your nodes out can help alleviate that. All right, so default language. We have 4 languages that we can select from. If I was going to create a new notebook, I can define what the default language is going to be in that. So if we're more used to working with Python, we can do that. It's considered PySpark, which is a Pythonic version of Spark. There's Scala, which was what Spark was written in. It's actually a language that was invented specifically to create the Spark engine, which is cool. And it's actually a pretty cool language. I call it a mix of Java and Python, right? Kind of dynamic programming along with this object-oriented programming at Python. So it has the best of both worlds in it. It's a cool language. Like native SQL, we got that. And then also R for all of you machine learning engineers that prefer the R over, or data science engineers or data engineers that prefer R over Python, then you got your stuff too. But that's always an argument that will be around forever. All right, so I can change this is the default workspace environment that's associated with this. If I had created a new environment that may have different libraries on there, then I could utilize that one in this. But in this one, the workspace default should apply. And then there's also another couple options that I can do. I can actually open up this notebook in my desktop version of VS Code or the web version. But I would, you got to make sure that you have permissions in VS Code to access. So there's a whole authentication thing that needs to happen from me working in Fabric in my own local notebook to doing it here from this web browser. So there's probably going to be some configuration you'll need to set up in the back end. Not saying that I couldn't do it from here, but I'm not going to try to break anything. All right. So we have the session, or we have our Lakehouse associated with this. So I know it's going to be pulling all the files or whatever it's calling out from my Lakehouse. I know that that's going to happen. So what I'm going to do is kind of go over the notebook experience itself. All right. And there's a few things I want to cover. Number one is the ability to highlight. So when you highlight one, it highlights all of the words that match that in the same cell. So that makes it really easy for me to find out where, if I set variables like df dimension date, if it's getting called out anywhere else in that cell, right? You can see that I got it in here and it's being called out a couple times. It just doesn't go by more than one cell. So that's one thing I can do. One of the other things that's contained within this is the ability to use IntelliSense. And the IntelliSense is really nicely built into this. So I can, start typing something out and then type something else out, and it will start thinking of what I want to do next. So if I wanted to hit another configuration object, I can do that, and then I hit that, and then set usually comes afterwards. And then when I run the arguments, it's telling me what arguments are required and what arguments are not required. Right? And it may already set those for me at some point, but that's the IntelliSense that's built into this. So I can tab complete. It does a really good job of taking a guess on what I think I want to be doing in this. And it's nice to have. Another cool thing about notebooks is that's different than other IDE formats is the way that we can utilize Markdown language. So this cell up here at the top is a cell. It's just like this. It's just not a code cell. It's a Markdown cell. So if I double click on this, you can see that this is just text that I'm inserting here. And it even gives me the option to format the text. And it uses, I believe, HTML5 to kind of render the Markdown cells after it's done. But when I click out of it, that's what how it ends up resolving. So this is a certain heading value, these signs here, and this is just regular text. Although I'm adding in things like these underlines will write it in a certain way. I think that might be italics or something like that. But again, it renders out. Now, what happens when I execute cells, like if I were to execute all the cells, it can identify a Markdown cell and it'll just skip over it. Now, another thing about notebooks is that it does execute all these cells in order. So I can't just skip one and come down here and select another one. If I set a value in here that's being called upon, like this dimension date, if I were to call on this dimension, if I didn't run this cell and I tried to run this cell, it's going to kick back an error saying it can't find DF dimension date because I hadn't executed this cell yet. So if a variable hasn't been set or something else is dependent on a previous cell, then it's going to kick back an error if it gets run out of order. So the cells get executed in order. Even when you manually run them, you'll want to run them in order. Unless you purposefully do something different, that's your business, right? All right. Now, I can also add code cells and I can also add additional Markdown cells to my notebook. So if I want to add a code cell, I can do that. I can delete it. I can add a Markdown cell and it gives me those options that I have here. And then I can delete it. And then I have options within the cell. So I can convert this to a Markdown cell or switch it back to a code cell. See, it just thought whatever this was to text. I can also clear the output for a cell. I can add comments, and these comments get saved with the notebook. So when another data scientist or data engineer comes in here, they can read the comments associated with this, add their own, and we're all collaborating with the same stuff. I can lock a cell. I can freeze a cell. I can also toggle this into a parameter cell. So when we talk about pipelines, this is one way that I can actually incorporate parameter values that I want to generically create in my notebooks that get called out from a pipeline. So I can make my pipelines dynamic by applying a parameter, toggling this into a parameter cell, setting a generic parameter value in here, and then changing that parameter in the actual pipeline without me having to go in and change the actual notebook itself, which is awesome. Now I don't have to change. Now my pipeline is dynamic, or I've made my notebook dynamic so that my pipeline can change based on what I'm trying to execute here. That's a little out of scope, but just wanted to point that out. There's also some other things that I can do with here, like I can move it up, down, hide certain things, or split it or merge it with another cell if I wanted to. All right, enough of that. We're going to execute this stuff. Now, I went over this in the Delta, creating Delta tables, but just so I'm explaining what's going on here. First of all, we created a session, and the session started very quickly because there's always going to be a node in the back end ready to go for this environment. What I'm doing is I'm setting configuration settings. And I'm enabling vOrder and I'm enabling optimize writes so that anytime I'm writing to a Delta table, it's performing compression techniques and partitioning techniques that are designed to work best with the Delta format of the SQL endpoints and downstream processes that I'm going to be utilizing from Power BI if I'm going to use reports for that. So that's what enabling that does. This is just more of me ensuring that it's there, but I'm also setting a bin size for the write files to say, this is what I want to max this out as. If it goes over that amount, just create a new partition for it, right? New file for it, so to speak, right? So here's what we're doing in here. What I'm going to do is I am creating data frames. I'm creating 3 different data frames. So if you remember, reading data in, I thought I had this associated with this. WWI, oh, I know why it's that. I know why it's that, because I named it something else, right? I named it sample LH1. Look at this. I can't use the, love it. Love it. Love errors because it makes me think, right? Makes me think. So we got to change this. All right, that should do it. Let's try. If I get an error 2 times in a row, that won't be good. It looks like it's running it now. So what we're doing here, see, I know how to fix stuff, I'm not just talking. All right. So what we're doing is we're running a bunch of Spark read operations. So I'm converting all these into data frames. I'm not displaying any of them. I'm just holding them in memory. So I've created a data frame called fact cell, dimension date, and dimension city. These are all data frames now. They're still tables in my Lakehouse, just in memory now. I'm pulling that data in and converting them to data frames so that I can perform Pythonic or Spark-related data changes to them. So because I have these in a data frame method, what I'm going to do is apply a bunch of different stuff to them. I want to make sure that I got the right... make sure that my, okay, so I don't see any WWI Lakehouse in here. Okay. And what we're going to do is we're going to execute this by Python because I got these in data frames. So dimension city, where's that? So I got dimension city here. I got dimension date here. And I'm joining these with fact sale by fact sale dates. So I'm essentially taking these tables and creating new data frames, a new data frame called sale by date city, and applying this. And all of these, by the way, whenever you see these dots, these are chaining. So I'm chaining all of these aggregations together or chaining all these methods together. So I'm performing a bunch of join operations here from these dimensions to the fact sale. And then I'm selecting certain columns out of those tables. I'm grouping them by other or the same dates in those or the same columns in those in those tables. I'm applying aggregations to it. So now I'm creating total amounts, right? Totals with the sum function. And then I'm changing column name. So this sum of this, total excluding tax, I'm going to rename that to a table called sum of total excluding tax and sum of tax amount, so on and so forth. And then I'm going to order by a certain date. And then I'm going to take this data frame that I just wrote. So this should be a data frame that contains all these aggregations and joins. I'm going to externalize that to my Delta Lakehouse or my Lakehouse as a Delta table named sale by date city, right? And if it's already exists, I'm going to override it. So that's essentially what I'm doing here. I don't think this should take very long. I know we're performing a lot of join operations on a lot of join operations on different tables, and that's what it's going to go through. The fact table is a larger table, so performing the join operations on that might take a little bit of time because I'm joining it by city key and the date on this one. So there you go, 34 seconds. That is not bad for me to perform all these join operations, aggregations, column renaming, and then sending this table to my actual Lakehouse. So what should have happened here is that when I go into my Lakehouse now, I have this aggregate sale by city, and it should have all of that, whatever aggregations I created, sum of total excluding tax, sum of profit. So these were what I added. These were those sum values that I added to the data frame. And since I already have dates and key values to this, I should be able to create relationships between this and other tables. So notebooks, right? Just thinking of anything else. Oh, by the way, when these outputs do get done, you could see that how many jobs were associated with this one execution. There's 29 jobs, right? And different stages associated with each one of these. All of these go as what they call a directed acyclical graph. And you could see, so I could go through step by step, and all this information is logged, by the way. So this is just more data I can analyze and see how long it's take for a compute to run. But I can go through these jobs and see the directed acyclical graphs for these from the Spark user interface. And it'll show me, the step-by-step, the stages that it completed, what happened during that. So I can get a lot of information off of the log files when these have happened, right? Here's the log files here. So it tells me what happened. I can also view resources associated with this. This is going to happen. So you'll always get an example of what's happening within these different jobs, and always get an output of at least what happened in the Spark job. But unless I'm explicitly telling it to output something, most of the time it isn't. The other thing I wanted to go through on notebooks, and maybe this is probably repeat information, is the ability to utilize magic operators within our cells. So I mentioned this before, magic operators can change languages. They can do other things. They can write to folders. They can write to files. They can do other things at the beginning. So I can create folders for something, and it'll just write to that folder. A single percentage point only applies that line. You see how all that disappeared? Now, if I were to write SQL language here, let me copy this to show you. Copy and paste. I thought maybe it would include that there. But usually when it's 1%, it applies to the same line that the magic operator is in. When you use 2% within it, then it applies it to the entire cell. And that's why everything kind of turns blue here, because now it's saying that I want to want to utilize SQL now in this. Now, how will I be able to do this? Oh, and by the way, it is calling on some, see this? Boom. So what I need to do is I need to change this, right? Sample LH1. This one. So I have all that changed. Now remember, I don't have any data frames created. I haven't changed anything. But if you remember, I already have tables. Now I can't perform native SQL operations unless it's in a table format. Fortunately, they're in a Delta table, right? So I should be able to run native SQL on these tables that have already been applied into my essentially my Lakehouse warehouse. So when I go back into here, what I'm going to do is I'm going to create a temporary view called sale by date employee. And then I'm going to be performing a select and again, providing some. Did I already have that? I just want to make sure I'm sale by city. So that's sale by date city. So that's not the same thing, right? We're doing this by employee, but still I'm going to provide some values, right? And then rename them certain columns. So I'm still going to add additional information like I did with the cities, but this time we're doing this by employees. I don't have this table yet, but since I'm calling on tables that are already in a table structure, like dimension date, dimension employee, and the dimension fact, this should go ahead and be able to process it because it's in that table format. So now I'm creating a new table, again, called sale by date employee. And that only took 4 seconds to run. So now when I go back in here, I should be able to see a sale by date employee. Maybe I need to refresh it. Did it finish that? Let's see. Order by, create or replace. Oh, because it's in a view. That's why. That's why I can't see it, because it's in a view. If I would have created a regular table, I would be able to see that table. Now, because I've created the view, I should be able to see it here. Oh, actually, there's one. See, I'm forgetting a cell. So now I'm doing select all of these from a view. Sometimes you want to write a temporary view so that you can perform a sanity check on it before you put it in a production level table. That makes sense. I think that's the thinking here. And what we're doing is then we're going to select everything from that table, right? So I'm using spark.sql context. This is another way that we can use Pythonic methods in the Spark engine to perform SQL queries on data. So this is just a string value that is a SQL query that I'm using the SQL method in order to parse through. Then I'm going to write it to a Delta table called aggregate sale by date employee. This will add the table into my Lakehouse. I didn't have it because it was a temporary view. So forgive me for that. So what I'm doing is I'm essentially pulling all the data out from that view, and I'm going to create a Delta table out of it. And that job's done. So now when I go back in my Lakehouse, now I should have another table. Sale by employee. So there we go. So that's notebooks. Notebooks are really great, especially these markdowns, because you can add you can add so much more detail into what you're doing from a step-by-step approach. It makes it easier for somebody to come back in and see what you've done with this. So the benefits of being able to create markdown cells and code cells, along with tagging parameters, utilizing IntelliSense and changing languages in between cells is just makes notebooks a great and dynamic way of everybody that works with different coding languages, whether that be SQL or Python or Scala or R. All of them can work with the same data in the same place in the same format in a notebook. So they're pretty awesome. that does it for this. Let's head back into the studio.
Congratulations, detectives. We unlocked the mysteries of Fabric notebooks to ingest and transform data from various sources, write data to a lakehouse in different formats, optimize performance and scalability, and consider different users and roles for data ingestion and transformation. Now, where did I put my notebook? Forget it, I have Fabric. Thanks for joining.